Section 2.9 talks about higher derivative. Really not that much difference than what we did. Instead of taking one derivative, you could take multiple. Example 1, find the indicated higher derivative, in this case y double prime. So if I take a single derivative, the usual, and if I take a second derivative, and there it is, done deal. That's it. And if I want to take 3 derivatives, if it's a polynomial, it's really not that much work. Actually, you notice if you take a derivative of a polynomial, you reduce the power by 1 every time you take a derivative. That makes it simpler and shorter. And if I take a third derivative, that would be 636, 30, I believe it's 336, I'm not sure of the numbers, but you know, there it is. So if it's a polynomial, it's really not that much of a deal or work, but if it's a radical or a fraction, then that might be a bit more work. If I want to take a second derivative, derivative of a square root is 1 over twice the square root times the derivative of the inside by the chain rule. So that's actually, if I want to rewrite it, that's negative 1/2 into 5 minus x to the negative 1/2. Of course, you are welcome to use the quotient rule if you like, but if I can avoid it, I would. If I can write it as a power function, the second derivative will simply be the negative 1/2, you ignore it, bring the power down, subtract 1 from the power, times the derivative of the inside by the chain rule, and if I clean it up, 3 negatives will leave a positive, a 1 over 2 times 2 is a 4, and this is the square root of 5 minus x cubed. And that's pretty much it. Again, you could use the quotient rule if you like. Here we have no choice. Well, we do actually, but you know, we could write this as x plus 3 into 2 minus 3x to the negative 1 and use the product rule twice. Or we could say, you know what, let's just use the quotient rule over the denominator squared. So derivative of the top is a 1 times the denominator minus derivative of the denominator, which is negative 3 times the top. Now normally I would be done right there, but since I have to take a second derivative, I need to clean it up. So that's going to be 2 minus 3x. Negative times the negative is a positive, plus 3x plus 9. So y prime would be 11 over 2 minus 3x squared. Now that's one derivative. I need a second derivative. I could write this as 11 times 2 minus 3x to the negative 2, just like I did here. But I am going to do the quotient rule in this case. This way you see both, and again, it's up to you. So if I'm going to take a second derivative, again, this is very quick. You bring the power down, subtracting from the power. Or you could say quotient rule. The second derivative is going to be the denominator squared. Derivative of the top is a 0 times the denominator minus derivative of the denominator times the top, and y double prime will be, that's a 0. That would be negative 6, negative times the negative is a positive. 6 times 2, 66 into 2 minus 3x. And you notice that 2 minus 3x cancels one of those. and you would have 66 divided by 2 minus 3x cubed. Similarly, if you were to multiply, that would be negative 22 with a negative 3 times the derivative of the inside, which is negative 3, and negative 22 times 3 is positive 66. And this is pretty much it for this section, really short section.